right, welcome to another CyberSec Tuesday, everybody. Tonight we have BarrySploit. He's going to be talking about uh, digital forensics and leveraging the Eric Zimmerman tools as well as the tool known as SuperTimeline to kind of help sharpen up your DFIR skills. This is in prep for our upcoming Null 44 CTF. That's going to be happening this weekend. But Before we get started with Barry, I just do want to do a quick shout out to our sponsor, ArcLight 6. They're an engineering and consulting firm specializing in cybersecurity, networking, and software engineering. So big shout out and thanks to them. Check them out over at arclight6.com. But Barry, it's all you. Take it away.
Appreciate it, Sean. Hey guys, my name is Jason Barry. Been doing security for too many years now, and yeah, this is kind of going to be our DFIR Digital Forensics Incident Response 101, taking us. Keep it as technical as possible. And if you're in the Discord server, if you check the general chat, there is a triage that I'm going to be using, kind of for the analysis. So kind of going through that process. So let's go ahead and get into it. So kind of starting, what is the basic process for our DFIR engagements? I'm not your lawyer, so we're not going to talk about all the legal things. We're going to keep it mostly on all the fun technical bits. From NIST, this is the overall kind of incident response lifecycle where you go from preparation to detection analysis, containment, recovery, etc. Right? We're going to be mostly focusing today on this detection and analysis piece, because that's where all the fun really lives. Don't want to give you a full CISSP course on how to prepare for incidents and stuff like that. Yeah, so that's what we'll be kind of going through. Do want to say, if you have questions, feel free to interrupt me at any time. I promise you're not gonna hurt my feelings, or drop it in the chat if it's nothing urgent. Otherwise, yeah. So generally what happens, right, is there's an incident that occurs, and the way that you kind of identify or find out that this happens can be a wide variety of things. It could be anything from you get a detection from your EDR that turns out to be a true positive, and now you potentially have an incident. Or it could be something as extreme as, hey, you didn't know the incident occurred until you saw the ransom note on your desktop, right? Hopefully that's not the case, but absolutely could be. But once we know that an incident has actually occurred, one of the first things we've got to do is start collecting all of the different artifacts, right? Ideally, we're starting with the things that are going to go away quickly, but we want to make sure we collect all those. We store a forensic copy of it. That way, if we do have to go through any type of litigation, or insurance claims, we have that copy, that we can use to say that the data wasn't tampered, right? Once you actually collected all of these things, now the fun gets to begin. We got to parse all those artifacts, know what those artifacts mean, and then start analyzing it to find the evil that's going on, right? Start answering all of those fun questions. What users are involved? What hosts are involved? What IOCs can we get? Things of that sort. Yeah, so getting that evil. So first thing being, collection, right? I'm going to keep it super short, but did say we want to get all those volatile sources first. So, for example, one of my favorite RAM capture tools is Dump It. Put a link here. I'll share the link to the slides afterwards, where you can go run Dump It. It dumps the entire RAM from your system, which on a lot of systems can be pretty large, so you might want to zip it up. But make sure you document anything that you do for this collection phase. That way, if you see it in artifacts later, you know exactly what steps were taken by your team to gather all these artifacts, right? So yeah, gather that RAM. It's got everything that's going on the system while it's actively running, so processes, network connections, etc. And then the other things that are kind of important with collection is understanding what's going to go away quickly, right? So RAM goes away the moment that we turn off the system. Things like firewall logs or some of your event logs, like the security log, those ones roll over fairly quickly. So if, for example, I've seen incidents where if we wait 48 hours to collect event logs, security logs already rolled over, and we don't have the login information that we're looking for when the incident originally occurred. So Definitely make sure you gather all those things first. When it comes to gathering things off the hard drive, we kind of have two options. We can either do this targeted forensic collection. Usually, you'll get this either through your EDR or something like Velociraptor or Cape, or a lot of firms have their own proprietary collectors. Um, and basically, what this does is we're targeting just grabbing the forensic artifacts instead of grabbing the entire file system. So, full disk is hey, we're going to go make a bit for bit copy of this hard drive. So that way we can get everything off of it, whether it's allocated or not. But as you can imagine, with modern, like my computer has 2 terabytes of storage, right? To transfer that all over the network, imagine I'm pulling it from like an AWS instance, can take a long time, right? So a lot of times what we'll do instead is do one of these targeted forensic collections so that way we can start analyzing and finding those IOCs as quickly as possible, right? So just a couple different areas there. If you are going to use a full disk image, if you are manually, you got the hard drive or laptop, etc., in hand, make sure you're using a write blocker. DKC Forensics did a talk a couple weeks ago where he talked about working in a police department. Has cool pictures and recommendations for some write blockers there. So not going to go into it too hard. But yeah, those are kind of the different approaches for collection. So once we collected all the different artifacts, we got to know what these artifacts actually are. What kind of value do they provide to us? I'm not going to deep dive into every artifact that exists, but I will kind of pivot to some cheat sheets where you can start viewing this information. You're going to end up doing research in a lot of your investigations. It's just part of the game. So making sure that you have information kind of readily accessible for yourself is setting yourself up for success there. So these are at least some of the common ones. So number one being the Windows event logs. So your security log, that's going to be everything that has your logon events or any items that are audited via your group policy. So some group policies, you can start looking at things like process creates. You'll see that in the security only if it's audited. You'll see things like users added to groups. Like you want to make sure you're auditing, hey, did somebody get added to domain admins? That's going to be in your security log. So tons of different auditing options that are there. Also, the system event log is a great place because, like I mentioned, the security log will roll over fairly quickly because it does fill up pretty fast. But system is kind of the collect all for everything else. So your services, your scheduled tasks, WMI, trying to think of other ones. Pretty much every service that you have running on your host is going to be writing event logs into system. So there can be an absolute ton of noise in there, but usually the retention on each one of those individual logs lasts a lot longer. So hey, we may not have had auditing on for scheduled tasks. So hey, not in the security log, but we might be able to pivot to system and get that same information that we're looking for. Right. And then the other one that I mentioned here is Sysmon. So Sysmon is not enabled by default. It's part of the sysinternal suite from Microsoft. Um, Absolutely 10 out of 10. Go install it. If you're a security engineer at your organization, you can get an absolute insane amount of telemetry from DNS events to network connections to process creations to name pipes being created to files getting created, registry keys being changed, everything that you're kind of looking for. Sysmon provides more visibility than some EDR tools. Like just that's just the way that it is. So Sysmon, absolutely 10 out of 10. Go set it up. It's awesome. So outside of a Windows event logs, kind of jumping into registry hives. So you may or may not know about the registry if you're not a Windows user, but the registry is basically a way that Windows stores information about every tiny little thing you do. There is not a whole lot of standards when it comes to the registry. So developers would just say, oh, I need to know the last 10 items that this person had opened with Notepad. Where can I store that information? Let me just make some random registry information for it. And so that information will be in there. How does Windows know if you go right click on Discord, right at the bottom of your list, you might see a few options pop up. You right click on your browser, you see things that pop up. Um, there's some files that are stored for that, but yeah, all that information that it stores about you is stored in the registry. So yeah, there's an absolute ton of information. So it's a pretty common thing for researchers to go after in DFIR. So but a couple things that you really need to know are that there are registries for specific users, so it's user-specific settings and configurations, and then also ones for computers, and they are stored in different locations. When I jump to the cheat sheets, I'll expand on this a little more, but it's a pretty important distinction there. So next on the list, we got master file table. So on your operating system, when you go click in Explorer to open a file, how does it know where all those ones and zeros are on the disk? All of that is going to be stored inside of the master file table. So the master file table keeps track of everything that has been allocated on disk. And it's stored at this location, just C $MFT. So if you want to see what was going on in the file system, go check out the MFT. Other things to quickly reference. So if you see LNKs, these are shortcuts or jump list files. That gives you a bunch of information on files that were accessed. There's also the user assist. This is a specific registry key that tracks GUI applications. Also includes information like how long was that application in focus for? How long did the user actually have that application, clicked and interacting with it? So cool information there. Prefetch tracks all of the files that were executed on the system. It includes things like the time it was last ran, how many times it's been ran, things of that nature. But it is not enabled by default on servers. And I actually struggled for a really long time to find information on how to enable it on servers because I absolutely love prefetch. So I did include the link here in the document if you want to go execute or go enable that yourself. Couple so let me pivot over to a couple cheat sheets that I have real quick. So, so myself, along with a couple other people that do this kind of work regularly, we kind of went ahead and put a cheat sheet together for everybody that's new to DFIR, as well as it's a great reference sheet. So, for example, kind of pivoting on here, I know I mentioned the registry just a little bit, um, but for example, you can see in some of these, you'll see HKLM. That stands for the local machine. That is going to be any registry hive that is loaded out of this specific path. Um, yeah, so we got a bunch of different information on here about even current users. It's referencing ntUser.dat for that specific user's path instead. We also go through a bunch of different file system artifacts, how to run some of the Eric Zimmerman tools on here, just quick little command lines, some of the different registry keys that you may want to look for, as well as, hey, here's where you can go download all these different browser artifacts, which we'll jump into a little bit later. As well as a list of tips that we had for beginners and some of our favorite tools for it's not uncommon to get scenarios where you have a user that says, "Hey, my device was hacked," and you're like, "Okay, what does that mean? What actually happened?" And you're just trying to kind of look for the needle in the haystack. Some of these tools like Hayabusa and Chainsaw are really awesome for that. They use Sigma or their own rules. Like Loki's great, Thor's great. So definitely go check it out. Logon Tracer is also a great one for beginners because it's a way to visualize Windows logon information. So it'll show you lateral movement via RDP and things like that. So awesome tools. Go check it out. Thank you to everybody who contributed to this list. Couple other things to show. So I just briefly touching on all the different forensic artifacts. If you want to know all of them, this red poster is absolutely fantastic for showing you all the different artifacts that exist and what they are for. So for example, I referenced prefetch. It is here under application execution, right? You can see all the other different ones that are there, as well as, hey, if we're looking for things like files and folder opening, etc., cloud usage, browser activity, account usage, network activity, USBs, all that information, great on here. I could do a whole talk just going through some of these artifacts, right? So, yeah, if you need a deep dive into some of these, or you're looking at like the SuperTimeline from Plaso and you're like, hey, what is this? Definitely come reference here. Other good one to know is this Sans Blue poster. So this one has kind of two major points. So one being what is normal on a Windows system. So Windows has a ton of different processes that run regularly. If you look at Task Manager, it's probably huge. So these are a lot of the ones that are built into the system that you'll commonly see. And it gives really great insight into what that process tree is supposed to be. So, for example, we can see SVC host here is underneath services, but we can also see SVC host is on here like 30 times, right? So it's pretty common to see on the system. And this sheet gives us that. But all of these are also underneath services.exe. If you ever see SVC host running where services.exe is not the parent, chances are it's malicious, right? It's pretty common for malware to spawn it and then try to inject malicious code into it, for example. So just some examples of showing you, hey, what is normal, so that way you can find what is anomalous. The other cool thing on here, if you saw my lateral movement talk, I covered a lot of this, but it shows the different forensic artifacts, including event logs and registry information for the different types of lateral movement. So whether that's remote desktop, mapping shares, using PSExec, scheduled tasks, services, etc. So two really good ones there. There's also ones in here for common registry keys and event logs. So like if we look at the registry one, you can see all of these keys are referenced starting with HKCU or starting with HKLM, being H key current user or H key local machine. You may not know that. If you're new, that's fine. That's why I put it here on the cheat sheet, right? So you'll see HKLM. Hey, that means we're referencing something out of this folder. If we see HKCU, we're looking at out of this folder instead. So kind of going hand in hand there. And then lastly, with this event logs, every event ID means a specific thing. So a 4624 means somebody logged on successfully, right? And there's also all these cheat sheet information of, hey, how did this user log on? So if you're looking at event logs and you see an event ID and you're like, well, I don't know what that means, check your cheat sheets, right? Awesome. Any questions so far? I know I'm kind of throwing a bunch of information at you. I see Sean dropped some links to good sysmon configs. Yeah, the Swift on security one is great. Olaf is also awesome.
Yeah, we'll note like if you don't add any configs, I think it by default it's very sysmon can be very noisy and can fill up like your logs pretty fast.
Yeah, definitely. If you have common things in your environment, you can even tune them out. If you're able to, if you're able to edit the configurations yourself, like if you run some background exes regularly and you don't need those logged, absolutely can exclude those by customizing your config. Yeah, Perseus, I'll share the link to the slides afterwards. Awesome. Cool. So we talked about a lot of what these artifacts are, but how do we get those into a format for us to actually understand? Yeah, we can go. We know what event logs are. How do we go look at them and use that to find things that are evil? So we really got to parse those artifacts. So there's kind of two ways to do this. I'm going to start with doing the kind of manual process where it's, hey, let's go pick a specific artifact. We're going to parse it on our own. That log specifically, that definitely gives you the most information. And then there's also the Plaso SuperTimeline, which we'll jump to afterwards, which it takes everything, kind of generalizes it, but then puts it into one CSV or Excel sheet for you. CSVs are going to be your friend when it comes to these things because it's the best way to start filtering and seeing things in a kind of timeline format to say, okay, this happened, but then what happened after that, right? You definitely always want to be asking questions. So kind of parsing things individually. So pretty much everything. I love Eric Zimmerman tools. Eric Zimmerman, I think he works at Kroll, and he's spent a lot of time doing research on all of these different artifacts and made tools to parse them. So yeah, Absolutely love those tools. If you want to parse single artifacts, sorry, let me take a step back. So there's kind of two different things that we can do with those tools. He has command line ones that pretty much all end in cmd.exe. And then he also has some GUI tools for things like Registry Explorer, MFT Explorer, Jump List Explorer. So kind of personal preference, whether you want it in a GUI or you want it in an Excel sheet, it works both ways. Um, and other things, you can target individual files with his tools, or you can target an entire directory. So for example, you can see on here I'm using MFT CMD, which parses that master file table. So you can see I'm using -F to point it at this MFT file, and then I'm saying --CSV, saying, hey, dump it in a CSV output into this folder. And this is parsing just one file, hence the -F. If you use -D, for example, I'm using EVTX CMD, which is the tool for parsing event logs. So I'm just going to point it at the directory with all of the event logs and then dump it all into one CSV. So now instead of going to Event Viewer and saying, let me look at Sysmon, and then you pull up security in another window and you're trying to cross-reference timestamps and things like that. Yeah, screw that. Put it all into one CSV. That way it's a million times easier. So that's kind of how most of these tools work, and I'll show you how to do that here in a minute. Now, browsers are pretty much the only thing that Eric Zimmerman Tools doesn't touch. So I'll have a couple different ways that we can do that instead. So we can either do a manual analysis. Pretty much every Chromium-based browser nowadays is SQLite. So pretty simple, easy to parse there. I like this GUI tool called DB Browser for SQLite. I'll show you that one as well. And then if you want to do some kind of automated parsing and analysis, Hindsight is usually my go-to, but I know a ton of people who really love Browser History View by Nersoft. Nersoft makes a ton of other tools on there as well, so definitely go. Cool. All right, and then before I get into the demo stuff, I'll stop talking here in a minute. Going to talk about Plaso. Plaso is a way to take all of those forensic artifacts and then put them into one output. The kind of challenge with doing a super timeline is that every artifact gives you a little bit of different information, so it's almost impossible to get all forensically valuable information and put it into one CSV. For example, prefetch has run count, right? But obviously, the master file table is not going to have a run count. It's for, hey, did this file exist on the system, not execution. So it's a little harder to go through, but it's really great if you have pivot points. Pivot points being, hey, I know that this file was dropped at this time. You make a super timeline, go find that pivot point when that file was dropped, and then look at the surrounding activity. That is definitely the number one way to use a super timeline. If you build a super timeline and just start scrolling through it, you're doing it wrong. So definitely go in there with some specific things that you're trying to pivot around. Otherwise, do some manual artifact analysis. Right, go run some of those quick win tools if you don't know where to start. Yeah, so Plaso Tools is made up of a couple different tools underneath the hood. So I listed off what I think to be the important ones here. So P-Info. Sorry, let me take one more step back. So Plaso Tools, it takes all of your full triage and it puts it into almost like a database, which then gets parsed into a CSV. It's kind of what it does on the back end. So P-Info will take that database and give you information about the triage, how many events are there, etc. And then log to timeline and P-sort end up working together. So log to timeline is what you're going to use to take all those raw artifacts, put them into a database, and then P-sort's what you're going to use to read that database and put it into a CSV. Now I know that's two steps. I'm a lazy admin guy. I don't like that. So most of the time I'll just end up using P-steal, which kind of wraps them together, uses both of them, so you don't really have to worry about it. A couple other things that you want to know, kind of that are important, are that you can specify what artifacts you want to target by using these parsers. And they do come in kind of pre-compiled lists. So in my example command line that I have here, I'm running psteel.py. I'm giving it a output format of log to timeline CSV. giving it where I want to write it to. So I wrote it as supertimeline.csv. And then I'm going to use this parser called win7slow. There's a list command you can see, but basically this captures pretty much everything. Um, Actually, I can't think of anything that this doesn't capture. So, and then you point it at the source. So where do you want to actually capture it from? Yeah. So Win7 slow is my recommendation. If you don't give it a parser, the default does not include MFT, a master file table information. So that's why I always specify Win7 slow. Um, Yep. And then there are a ton of different outputs that you can see here. So, for example, there's a dynamic output, which is the people who make this. That's what they recommend is using dynamic. I actually like log to timeline. CSV gives you 17 different fields, and that's just what I'm used to because it's kind of legacy. So. JSON is great if you're trying to take all this output and then ingest it to some sim that you want. And then other thing that I absolutely love is Time Sketch. It's a tool actually made by the Google DFIR team. That's basically a tool where you can just take the output, take that database from log to timeline, and then upload it into the GUI, and then start searching every single field. No problem at all. So I'm actually going to go jump over. I'll show you. Let's do this. So um, first, I'm going to show you. So this is Time Sketch. I'm not going to do a whole presentation on it, but essentially what I did is I took this database. You can see it's timestamp-c. This is the database that I was working with, and it is uploaded in here. And we can pretty much search it just like you would with any sim or log tool. So if I just go in here and put star, for example, to get a whole lot of different information. We can filter based off of the different data types so you can see what forensic artifacts did they come from. So like, for example, let's go look at some Chrome stuff. Let's look at pages visited and files downloaded. So if we do this, we can see, so it looks like it's filtering, it's going down. So this is one of the first things that they went to. See if I can add some other columns on here. Anyways, okay. Don't want to spend too much time in this tool, but you can see all of these raw fields that are here, and we can filter on these. So here, for example, hey, this guy's installed the installer for League of Legends. If we wanted to filter for that, I could just click here, filter, and start filtering for that. And you can see here's all of the different information that's there. I'll show you in the timeline explorer as well. In the CSV, it does not get this specific where we get to see all of these specific information. It's pretty nice to have it in a GUI tool like this. And if you already work in the field and you're looking for tips, I like this tool because you can add tags to things, so you can mark things as, hey, this is suspicious, this is evil. You can star things. So then you can take this full timeline and then have something almost presentable to leadership and say, hey, here's all these key logs that we found that kind of tells the story of what happened in this incident. Right. So cool. So that's Time Sketch. Let's go ahead and I'm going to show you how to run some forensics tools. So I'm going to pull up my PowerShell here. Are you able to see my window?
Yep.
Cool.
Yep.
Awesome. So I went ahead and extracted the triage that I put in the general chat. I went ahead and extracted that here. You can see I already pre-processed these timelines. They do take a really long time, so didn't want to have us sitting here for 10 to 15 minutes while it parsed these. So, yep, listed those out already. So a couple things we can do immediately. So we know, hey, this user definitely downloaded some stuff. So that's where we're going to start. We're going to start with some browser information. So mentioned that there's an automated way and a manual way to do these things. So let's do the manual way first. So my go-to tool for this is DB browser for SQLite. And then once it's open, I'm going to go ahead and go find that user's history. So if I go directly to D for demo, and then we know the user in question here is going to be this local user. I'm going to go ahead and go find their, I'm going to the wrong path here. I'm going to go find their Chrome history. Yep, here we go. See, and it's not even a .SQLite, so it's a little misleading there. Now, this tool, once we actually load the database, it'll show us, this main page shows us, hey, what tables actually exist. If you're not familiar with SQLite, it's basically just a collection of a bunch of different tables, right? I think of it as a bunch of different Excel sheets. If you're a database admin, please don't kill me for that. But that's how I simplify it in my head. So shows us the different database structures that are here. And then if you want to actually view the information, we have to go here to browse data. And then we have to select which table we want here. So in this case, we're just looking at cluster keywords. So you can see some of the different things that people have Googled. It looks like my toddler took a hold of the browser at some point and put a bunch of threes. But you can see, hey, this person Googled how much Battlefield 6, Libra horoscopes, places to eat, League of Legends downloads, best AIs, etc. We can go take a look at the downloads. We can also take a look at the different URLs that they did. So let's just take a look at the URLs first. See if we see anything suspicious. So we can see they kind of did their Google search for what is the best AI. They went to Reddit for ChatGPT. They said what is authoritarianism, looked it up on Wikipedia, went to YouTube. Looks like they watched some League of Legends on YouTube. Looked at some American Airlines things from Denver to Italy. 5882, that's pretty good. How much is Battlefield 6? And then they went and looked at it on Steam. Nothing too crazy here. Now let's go look at downloads and see if we see anything weird. So we can see they definitely downloaded these League of Legends. Looks like they downloaded it 4 times. And then they also downloaded this Chrome update.zip. I don't know about you, but I don't ever download zips when I'm updating my Chrome. So yeah, we can see last access timestamps. We can see the URL that they downloaded it from. So in this case, it's not even an HTTPS, and then it's going to this directly to an IP, not a domain name. So that's definitely pretty suspicious. So, but we definitely had to do a lot of digging for this, right? We had to go through multiple different tables and find out all this information. So this is the manual route if you want to go through someone's browser history. But the automated way to do this is to use a tool like Hindsight, which is my that's what I like the best. And it puts it out in an Excel sheet. So it's not super pretty if you don't have Excel, which I don't on this host, but we're gonna do it anyways, and we're gonna have it. We're gonna do it. So the way that we do this, if I run Hindsight, there's a couple different inputs that we really need, but the most important things is just run Hindsight with -I, and then do -O to where you want to actually put the file. So if I do /hindsight.exe, because it's in my current folder, and then all you're going to do for this, part of the reason I love Hindsight so much is that it will recursively look for all browser information on a host. So it's not something where I have to go, follow that crazy path to go find the user's history. I can just point it at the C drive of the triage, and it will parse the browser history for Chrome, Edge, Firefox, all of those Chromium based. Sorry, not Firefox. I don't think it's supported with this one. But it'll go parse all those Chromium-based browsers and put them into one Excel sheet for you for all the different users. So I'm just going to do -I, and then I'm going to point it at that triage there, point it at that C drive, and then I'm going to actually I'm going to put it output in that same folder, and then let's just call it out. Let's call it Hindsight out, and then we'll let it run. Oh, did not like it. Say unrecognized argument. Oh, it's capital O. It's little o. Sorry. Cool. And as simple as that, you can see looks like it ran it against a couple different users. We can see local user using Edge. They used Chrome. What records came from each of these. And then here we go. We have an output file there. So if I go and open this, I'm going to be using Timeline Explorer just because that's what I got on this host. On Excel, most of these will be different colors, so it's a little prettier to the eye, but also gets you a chance to use Timeline Explorer, which is a great filtering tool that was also made by Eric Zimmerman. So pretty nice there. Um, cool. So now that we're on here, what we'll do, you can see here's this type field where it has, hey, was it from a preference? Was it from a cookie? Was it a site setting? Was it a URL? Was it a download, etc.? And if you don't know what's here, for example, great thing with Eric Zimmerman tools, you go to the column, click this little filter icon up here, and it shows you all the different things that show up in this column. So if we just want downloads and URLs, right? Now we just have those. Um, yeah, so we can see all the different URLs and the download here at the bottom. So yeah, pretty good information. Um, I like having it all in one Excel sheet. Any questions on this? Those are kind of those two different ways for us to parse browser information. Cool.
Don't be shy.
If not, that's okay. We kind of do have a point that we can start going and looking at some information now. So, like for example, we can see that this person downloaded this zip, right? Chrome did not mark it as dangerous, so that's interesting. I guess it's because it's a zip. But for example, what questions would you be having next, right? It's hey, what was in the zip? What actually was in there, and we're not going to get that from the browser information. We're definitely going to have to pivot to some host based information. So what we'll do is we'll go ahead and parse the MFT, which is that master file table, and kind of look and see what else was in that user's downloads. Did they extract this zip? Maybe, maybe not, but it's worth us taking a shot. So yeah, let's go give it a shot. So I'm in my forensics tool folder. Let me go ahead and change to my MFT. Uh, Craig asks in chat, what do you use for Firefox since it's not Chromium? Anything specific recommended differently? Nothing. I want to know. I wonder if the NersSoft tool does it. It's also SQLite databases, so usually if it's just a one-off, Plaso will parse it all because Plaso's fantastic. Or you can go do it manually with the same DB browser. Cool. So just looking in here real quick, I'm going to go ahead and grab that MFT ECMD. And just like we saw in the cheat sheet, right? If we go down here, we can see, hey, we're going to be running Hayabusa. Where'd it go? Well, if not, I mean, here we go. Yep. So MFT CMD, and then we do -F pointed at the MFT, and then tell it where we want to output the CSV. So go ahead. We're going to do exactly that. -F pointed at the triage, pointed at the C drive, and then on here we have $MFT. We'll do -CSV, and I'm going to dump it into that same folder where the triage is, just for the sake of keeping things clean. And then it'll take a second to run, but it'll go ahead and parse all of those records in that master file table. Cool thing with these tools too is you can run these on live systems. If you're using something like Cape, for example, I know I referenced that Cape can be used to collect all this information, but you can also build in all the Eric Zimmerman tools to run as modules. So it collects it, runs all of these, and then dumps those CSVs into another location. So processing, more processing things, right? That you can add in there. Cool. So looks like it outputted it here. File size is pretty large, but let's go ahead. I'm going to go ahead and open it up. taking a second to load because the file's a little large. So here we go. So now that we're in here, so this is all the information that you actually see in each one of those master file table entries. So if we take a look at all the different columns that are here, we can see there's the entry number, doesn't really matter to us too much, sequence number, parent entry number, all this information to kind of for the file system to know, hey, where is all of this stored, and what sequences are they in? And then there's is that file actually in use? So is it allocated or not, as well as parent paths and what file it actually is. There's a file size on here, as well as all of the different timestamps that are on there. Fun fact, there's actually two different sets of timestamps. They pretty much should be the same. If they're not, one's previous to the other. Like, depending on the operations, that red T or the sans red poster has all the information for what actual timestamps change based on what actions were taken. So you copy a file, what timestamps get updated. All that information's on that red poster. But what we're going to do here, we wanted to take a look at that user's downloads folder. We know it was local user. So let's go ahead. We'll come here. I'm going to click that little filter button. Real quick, sorry. For anybody that's new to this tool, a couple of things that are important to know. For these, you can right click any of these columns and click on this column chooser, and you can see any other columns that aren't shown by default. You can broadly search across the entire CSV, so it doesn't matter what columns it's in. And then you can also filter based on the specific columns. So in this case, we could do contains, not contains, is like, etc. What we're going to do in this case, I'm just going to come up here and I'm going to search downloads. You see there's a couple different folders on here. We can actually see already in here, there's a folder called Chrome Update inside of downloads. So let's just go take a look at both of those. All right. And then I'm actually going to move some columns around real quick. So let's do this. Let's take this created column and I'm just going to move it right here. Cool. So now we can see the path, what's the file, and then when it was created. So we can actually see on here, here's where this folder was created. Here's where that folder was downloaded. There's also this zone.identifier. This is also known as an alternate data stream. Any files that you download from the internet or intranet, etc., has this information that tells you where it got downloaded from. So even in this case, we can, if we go look at the zone ID contents, we can see, hey, this was downloaded from zone ID 3, which is the internet. And then here's the actual URL that it was downloaded from. You can see the same thing for that League of Legends download. Cool. So we can see they downloaded it there. Now let's take a look at what was actually inside of that folder. So in this case, we can see, hey, here's this Chrome update. And there, it looks like there's a PowerShell script inside of there. So there's this update.ps1. Suspicious. You can actually even see on here, because it was extracted, it takes the alternate data stream and shows that it came from that zip. So cool little tidbit of extra info there. So,
Question, Barry.
yeah, go ahead.
I just noticed that there's a created OX10 and a created OX30. Do you know what that means?
Yeah, so I'll pivot to the cheat sheet here, but essentially one of these, let's see if I can zoom in a little here. One of these, admittedly, I don't remember off the top of my head which is which, but one of these is the standard information, and then the other one is, oh, are they not on here? Am I crazy? Oh, I thought it was on here. I'm so sorry. One of those is the standard information timestamp, and the other one is the $ file name timestamp. They generally should be the same. And for example, a lot of this, how we detect time stomping, for example, if one of the timestamps is changed, because I think it's just the standard information. So like if we look here, right, there's all of these timestamps that show up here, right? So we have a created, modified, accessed. When attackers change timestamps, these are typically the ones that they change. And I believe this is the standard information timestamp. So if we see, hey, the standard information timestamp says this thing's from 2 years ago, but we see that the $ file name or the X30 timestamp says it's from yesterday, potentially was time stomped. So, yeah, just cool extra tidbit there.
Cool.
Is
Thanks.
that, yep, no problem. Yeah, great question though. Love that. Cool. So we can see, yep, there was definitely this update.ps1. Now the kind of next question here is, did the user run this, right? Did they just download it, extract it, and go, this is a bit suspicious. Maybe I shouldn't do this and not run it? Or did they run it? So now we need to pivot to another artifact, right? I'm actually going to go ahead and show you how I run Plaso. So I typically run Plaso from WSL. I found it easiest to use Plaso from a Linux box. Don't know why that's the case. I just personally have not gotten it to work on Windows very well. So, but yeah, so we have all these different tools like log to timeline, .py, right? This is how we create that database. Also mentioned there's pinfo. So all of those things, we can install them through pip. I'll drop the documentation. I'm pretty sure is in the cheat sheet for how to set this up. But my go-to is psteel.py. So if we take a look at all the options for psteel, most important things are going to be the output format. Where do we want to write the actual output file? What parsers do we want to use if we want to specify them? Like I said, I like using that Win7 slow, but the standard default one works just fine too. So we go take a look here. Oh, thank you. In this case, I think I did psteel, and then we did -- source. I pointed it at the path to the D for demo. So in this case, did like this. Did -- parsers, Win7 slow, which in this case, like if we do -- parsers list, it'll show us all the different parsers that are kind of there already. So for example, we're using Win7 slow, which does this ESCDB, the MFT, as well as everything inside of Win7. So in Win7, we got custom destinations, file history, user access, everything inside of Windows generic as well. We could follow this path down, right? But for example, if you just need to do web history, you can just specify web history, and this is everything you're going to grab. So Opera, Chrome, Firefox, it's like Java IDX, a lot of really good information. If you need to do targeted things, that's how you can do this. Those are kind of those pre-compiled ones, or you can reference the actual individual ones yourself. Like I said, I like to just do the Win7 slow. Then we have to give it an output format. If we take a look at all the different output formats, there's a few good ones. Dynamic, I'll show you the difference. The two most common ones are log to timeline CSV and also dynamic. I'll show you the outputs from each of those. And then you can also just put it straight into an OpenSearch database or straight into some raw JSON. Raw JSON's great if you plan on parsing it with something like Python. Let's just go ahead and jump into it. I don't want to have this run because it's going to take way too long and I don't want to take up a bunch of your time. So this is the log to timeline CSV format. So I ran this on that same triage. I'm going to go ahead and sort by timestamp. And then we can see there's a column for what the actual source it came from. And then there's this huge long description section that tries to store all of the information about that artifact. So like, for example, if we come in here and let's do this one and we'll just look at web history. So if we come in here, we can see, hey, we're looking at Chrome cookies and here's all these cookies that were here. There's web cache information. Whole lot of info, right? Even just from one source. So here's some URL visited. Oh, yeah, here you can see it looks like they did actually end up opening the update.ps1. Did they run it? I don't know. This is still just part of the web cache, so they viewed it, not necessarily that they executed it. But yeah, there's a whole ton of info in here, and it's kind of hard to scroll through because it's all in this one field. Like I said, you can click up here and do column chooser, and I don't know why it popped up over here, but there are some other ones. Like if we want to see username, host name, information like that, we can get that. Yeah, but it's a bit hard. So let's do this. We know that the file is update.ps1. See if we can find it. So we have this. Looks like all of these other things reference it too. So we can see these are all coming from the actual PowerShell source, like from the PowerShell event log, right? Because it's WindyVTX. So chances are not looking good, especially considering, hey, here's this URL that was visited, and then yeah, here's all these PowerShell logs afterwards. So yeah, so sorry, it looks like it filtered the wrong way. So here's where we actually have it downloaded. Yep, because here's the file entry, and then we can kind of follow this up. Here's a 4688. This is a process creation event, and probably not looking too good. So looks like this user probably did execute this if we're seeing this in here. So if we double click into the event, here we can see the raw info from this event log. So process ID information, what the username was, the host name was, process name is PowerShell, and here's the command line that was used. Yep, so process was created pointing at that update.ps1. So this thing did run. Well, so we know that some evil has ran on the host. We have this super timeline. We have all these other artifacts that we can use. Now the question is going to be, what does this PowerShell script actually do? So my challenge for you is, so this PowerShell script drops some files onto disk, and it also sets two different forms of persistence. Um, if you're able to find those, or you think you find those, please DM me, and I'll validate you. Or if you have any problems kind of going through this and you're like, hey, I don't know where I'm looking, please let me know. But I'm going to stop the investigation here on my end, so that way you can find, hey, what did this PowerShell script actually do? What did it drop? What persistence did it set? What would we need to do to clean up this host, right? Yeah. Yeah. So thank you guys for coming by talk. Do you guys have any questions?
Yep, I have a quick question.
Yeah, go ahead.
So for the logon tracer, that's kind of cool. I haven't seen that tool before. Does that run pretty quickly? It looks like it's all Dockerized. Like, is that just dumping in the logs and it'll just automatically run, or what kind of use cases have you seen for that, basically?
Yep. So, admittedly, it's not the. I got it from a buddy of mine who highly recommended it for people that are new. But my understanding is, yeah, you spin up the Docker container. It has a web GUI, and then you can just drag and drop the security event logs in there, and then it'll map them all out for you.
Okay. Can you can you like drop them into a folder in the Docker container and like ship them there somewhat, like with a script or something, and have it run automatically?
Ooh, I don't know, but that's a good question though, because that would be pretty great for like, if you just want to spin up a Docker instance for your incident and feed it in there by itself.
Yeah.
But I know it does just use some security event logs. So, like, if you're seasoned in this and you're used to looking at like 4624s and stuff like that, you may not get a whole lot of value out of it. But it's a great way to visualize it for people that aren't super familiar with those event logs.
Mhm. Cool. No, and that's kind of the angle I'm looking at this from is, especially some of these tools, if there's a way to help automate some of that stuff, especially for newer analysts, because then they can just go to the web GUI and they can just be told, yeah, go to this web address if you're lost, and this will give you some places to start. And if we can automatically ship those logs there, so they don't have to worry about dragging and dropping the right logs or whatever, just try to minimize any sort of human error.
Yep,
But, okay,
absolutely.
cool.
I absolutely recommend using Plaso if you're looking for some kind of triage analysis. I've helped organizations use Plaso where you use JSON to feed into something like, I work at CrowdStrike, so feeding into NextGen SIM. Or I've had orgs where they take all of the output from Plaso, upload it to like an S3 bucket, and then there's just a cron job on the instance that's running TimeSketch to import all the new timelines from that S3 bucket. So, yeah, the Plaso makes everything like super readable. If you're going to ingest it into another tool, I recommend doing either JSON or TimeSketch.
Okay, that makes sense.
Yep. Yeah, good questions. So, hey, what else you guys got? Any other questions? Cool. If not, I will stick around for a little bit, and I'll drop those specific questions in the chat, um, just in case you want to tackle it yourself. Definitely recommend these. These are pretty like standard detections. If you've never worked in a SOC, these are the type of things that, hey, you definitely want to go be able to investigate these types of things, whether it's from telemetry you get from your EDR or from things like event logs, for example.
Thanks again, Barry. Hey, great talk. Appreciate it. Do you have any other suggestions you can give for the group to for like studying for the CTF for this weekend?
This is almost like a little sneak peek into how the type of information you're